So we started off this chapter talking about two major forms of energy, and those are potential energy and kinetic energy. There's a lot of other forms of energy too, in addition to those. So we're going to talk about 6 other major forms of energy. There's many more on top of this, but we're going to stick to these 6 that you guys will be responsible for knowing what they are and how to identify them. So the first one we're going to look at here is thermal energy. So thermal energy has to do with both potential and kinetic energy. So it's the total potential and kinetic energy of all of the microscopic particles that make up an object. So this is a result of the movement of those particles. So when those objects, atoms would be what those particles are, okay? When they move faster, its thermal energy increases and the object becomes warmer. So when you put something in the microwave, you're actually increasing the thermal energy of those particles. You're increasing how fast they move. So that's what makes that piece of pizza or whatever you're putting in the microwave warmer, because you're increasing the speed of those particles. So therefore, if you were to increase the temperature of anything, you are increasing the thermal energy. If you have an increase in one, you have an increase in the other. An example of a place where we see a lot of thermal energy is when we're melting down different kinds of metals, usually for like recycling purposes. Molten metals contain a lot of thermal energy because it takes a lot of heat and a lot of increase in temperature to melt them down to a liquidy type state in order for them to be changed into different kinds of things. Okay, so that's thermal energy. Now, nuclear energy, if you can guess by the name, has to do with the nucleus of an atom. So the nucleus of an atom is held together by the strong and weak nuclear forces. So different particles within the nucleus are held together by different forces. And within those forces, those bonds that hold those particles together, those hold a lot of potential energy. Okay, so nuclear energy is a type of potential energy. This is known as nuclear energy because it's stored in the nucleus of an atom. The process that we use to release this kind of energy is called nuclear fission. Okay, so nuclear fission is when an atomic nucleus is split apart. So this is the kind of stuff that is used in like nuclear power plants, is nuclear fission. They release the energy that is contained within that nucleus in order to harness the energy that's provided. Now, on the opposite side of that, nuclear fusion will release energy when 2 nuclei combine to form one bigger one. Anytime that you put 2 things together, that will also result in a release of energy. So in both of those cases, we have some kind of energy release. They both would release nuclear energy. Nuclear fission is the splitting apart, so breaking apart, the fission. Nuclear fusion, fusing together, putting together 2 different nuclei to get more energy out of it. So that's nuclear energy. Now, chemical energy is probably one of the most common types of energy that we come in contact with on a daily basis because it's occurring in our bodies at all times. So chemical energy is the energy that is stored within chemical bonds. And when those bonds are broken or formed, energy is going to be released, just kind of like we saw with the nuclear energy. All chemical compounds are going to have some kind of stored energy. So this would also be a type of potential energy. A thing that commonly we talk about that has chemical energy would be fuels. So like coal or gasoline, those have chemical energy stored within them, and we release the energy by burning them. Another example would be the foods that we eat. Our bodies break down those bonds in order to release the energy for our bodies to use. Another good example is burning wood. That's another fuel source. Okay, so you are setting a fire so then you can roast some marshmallows or something. That's what we call a combustion reaction that breaks the bonds within that piece of wood, which then produces thermal energy and also a little bit of light energy because you can see the fire and you can feel the heat off of the fire. So a lot of times we're going to have a kind of transfer of energy when you see these different bonds being broken or made. But the potential part of it is the chemical energy side. So the fact that it has chemical energy means that it has some kind of potential energy, is the potential to turn into another form of energy. Now, mechanical energy kind of relates that potential and kinetic energy that we had talked about originally. So the energy that's associated with the motion of everyday objects is what we call mechanical energy. So a prime example of this would be like a roller coaster car, is that constant transfer between potential and kinetic energy. We see that in all moving objects around us. There has to be some kind of transfer of potential and kinetic energy. We also call mechanical energy the sum of an object's potential energy and kinetic energy. So anytime that you add together your potential energy and your kinetic energy, you will get your mechanical energy. Okay. You can also use that amount to find either your potential or your kinetic energy. So if you were to take the mechanical energy and subtract your potential, you would get your kinetic and vice versa. So mechanical energy is super helpful in identifying either potential or kinetic energy or relating those two together. Now, electromagnetic energy is an interesting kind of energy. It is a form of energy that travels through space in the form of waves. Okay. This is what makes light happen. Electromagnetic energy travels in waves just like light does. So that's how visible light happens, is through this kind of energy. Another example is X-rays. So X-rays, like if you go to the doctor to see if you have a broken bone or something like that, the X-rays that are used to produce that image are also a form of electromagnetic energy because they travel in waves through space. Okay. Now, when we talk about space, we just mean through any area. So that could be through actual outer space or through our atmosphere here. One example here would be these lightning bolts in this first picture. So they transfer electromagnetic charges. We see the light from those lightning bolts. So that visible light is a form of electromagnetic energy. Another example is galaxies. Galaxies are these giant structures in space. They contain billions and billions of stars, maybe some planets and stuff too. Now, those stars that are found within those galaxies give off enormous amounts of electromagnetic energy. Our sun, for example, is something that gives off electromagnetic energy. It gives off visible light because it provides light for us to see. It also gives off ultraviolet radiation, which is another form of electromagnetic energy. It gives off infrared radiation, which is a part of heat energy as well. So lots of different kinds of electromagnetic energy are given off by stars. Our last example of type of energy is electrical energy. So don't get this confused with electromagnetic. Electromagnetic is anything on the electromagnetic spectrum. So visible light, X-rays, UV, infrared, radio waves, that kind of stuff. That's all electromagnetic. Electrical energy has to do with the energy that's associated with electric charges. So this is going to be the stuff that powers all of our electrical devices that we use on a daily basis. We're using them even more now doing all this remote school stuff. So electric charges exert forces that do work. Okay. Now remember, back to the beginning of this chapter, we can't have energy if no work is done, and we can't have work without forces. Okay. So the forces make those electric charges move, which causes them to do work, which creates electrical energy. So some common things that are powered by electrical energy would be things like batteries, generators, and all the general electronics that we use on a daily basis. Those are the places that you most commonly find electrical energy. So there are our 6 major forms of energy that we're going to go over in this chapter. Make sure that you have answered all of the questions within this video, and you have filled in your notes completely from these slides. So the note packet that you had from when we were in person, you will fill in using these slides. Make sure all of the questions in the video are answered, and then make sure that you hit the submit button at the end of this video, so then your grade for this can be recorded.